So just thinking about what problem do you see there? Turn and talk to the person sitting next to you. What problem do you see represented?
I see 660 on the one side and
Okay, so talk to me. What did your partners say about what problem they see up here? What y'all see back in the back? You see 60 minus 27. Does everybody see that?
Yeah.
So let's watch. I'm going to show you how this problem was solved, and I want you to think about what happened. Are you ready? So the person that solved this problem, they did this. Then they did this. Then this. Turn and talk to your partners. What just happened in that problem with those manipulatives? Here, let me show you two again. Ready? They did this. So imagine you had this in front of you. Then this and that. Why are they doing that? What's happening in this problem with this picture? Talk to your people. All right, come back with me. Who wants to share something that they see going on, something their partner said? Talk to me in the back there, the blue screen. Yes.
So, Grady said that they were grouping and turning that 10 into 10 ones.
Oh. So in this, what did they do first, though, when they first crossed out these lines? What were they doing there? What were they doing there?
They were taking out the same amount on each side.
Ah, so they were taking out the same amount on each side, right? I got 10 and 10 here, I got 10 and 10 here, I'm going to pull them both out. And then, sweetheart, you were saying they were that Brady said they were regrouping. Why would we need to regroup here? Why would someone do that? Yeah.
To get an easier way to just subtract the ones on in the 27.
No, because how many ones did we have here? 7. How many ones did we have on this side before we regrouped? None, right? And like we talked about in the number talk, it's kind of hard to take away when they're not there. So they regroup. So what are they going to do now, you think? What do you think? Yeah.
Subtract 7 from those 10 ones they made.
Look at you. So yeah, same thing. So they're subtracting those 7 ones out. So what is our answer? What's our difference?
33.
33, right? So a lot of regrouping happening there, okay? And I want you to think about that because today in the lesson that we're going to talk about with mixed numbers, we're going to be applying some of these whole number strategies. So think about what you're seeing here. I want to show you another strategy to solve this problem. I want you to make sense of it. Are you ready? Look at this little number line. Take that in for a second. Look at that representation of this same problem. Talk to your group and your partner about where's the difference. In other words, the answer, which is the difference to an answer to a subtraction problem. And what did this person do to solve this problem? Turn and talk. What did you and your partner talk about here? Where's the difference and what did this person do to solve the problem? Talk to me, honey.
Well, they labeled everything on the number line first, like 27 to 30. Because 3 plus 27 equals 30. That's why there's the little 3 bar there.
Oh, okay.
And then,
But why did they start at 27?
because that is the smallest number.
Oh, so they started here at 27, okay, and then they counted to the next friendly number, which was 30. Keep going.
And then they did 30 plus 30 equals 60. And they did that because there's 60 on that side.
Yeah, so they stopped at 60, right? Could you have gone 10 and 10 and 10? Yeah, but this person just said, hey, it's faster if I just jump 30 at once, right? So where's the difference in this representation? The difference was here in this representation. Where's the difference?
It's on a number line.
Yeah, but where is it on this number line? In the what? Where do you see it?
In the tens place?
What do we call these when you're The skipping, the jumps. It's in the jumps, right? So the difference is 33. It's in the distance between the two numbers, right? So we have regrouping. We call this, anybody know what you call this strategy? Adding up. You ever heard that before? Adding up. So we're starting at one of the menu end, and we're moving up from those pieces of our subtraction problem. So counting up. So I'm going to show you one more, and I want you to keep these in mind, remember, because we're going to be working with subtraction of mixed numbers today. I want you to think about the regrouping. I want you to think about the adding up, and then what in the heck is happening here? Look at this person and how they solved this. This is Rosie's way. Rosie solved it like this. Look at the problem. Look at the problem. Look at the representation. And what is happening? Now turn and talk to the people sitting with you. Make sense of this. What is Rosie doing to solve this problem? Okay, so come back with me. Talk to me about Rosie. What's she thinking here? What'd she do to these numbers and why did she do it?
The zeros you can't, there's a lot of regrouping when you do 0 minus 7.
Yeah.
And if she just took one away from both of those, she could have done it easier and then added 2 at the end.
Oh, okay. So she didn't like to regroup with a 0. Are y'all kind of the same way? Like, I don't like 0 regrouping. We saw it in the first model, didn't we? We can regroup, but Rosie just took the numbers on the number line. She started here, look, 60 and 27. She just went one step. Do you see what she did? One step on the number line and took those one step. What happened to the distance between those numbers? Did it change? Not one bit. So the distance stayed the same. Turn and tell your neighbors why you think the distance or the difference stayed the same. Why is the difference staying the same?
First number, what number? So this they all exist twice. So say this was
All right, so come back with me. Why did the distance or difference stay the same when she moved them and changed the problem to a totally different problem? Back in our number talk, sometimes when we added numbers, we had to subtract them, or when we subtracted them, we had to add them. Why this time do we not?
Because she's taking an equal amount from each side.
Oh, somebody tell me what he just said. Somebody tell me what you heard him say. Jada, what did you hear him say?
He's taking an equal amount from each side.
Oh, so if you take the same amount from both problems, both numbers, they stay the same, right? The distance stays the same. Interesting strategy. What do you think about that strategy? Interesting, right? Yeah, it's something to think about using. So for today, I've been alluding to what we're going to be doing. So what you're going to be doing today is applying whole number subtraction strategies that you are aware of or that we just talked about to subtract mixed numbers. I hear you've been working on some mixed numbers. Yes? Sound familiar? So you have your mixed numbers that you've kind of been dealing with, and you have some manipulatives that are in front of you, which I'm going to let you use as part of your exploration. But I also want you to think about these strategies, and I'm going to label them up on the board. The regrouping, the adding up, and the keeping the difference the same, or the distance the same. And I want you to think, can I use one of those strategies to help me solve the problems I'm going to encounter today? Okay? Because part of your success criteria, or your success criteria for today, is that you're going to know you've learned how to apply these strategies when you can explain it to me, and show me with a model or explain it with a model. Are you with me? Turn and tell your neighbor what you're doing today. Okay, so somebody tell me, what are we working on doing today? Subtracting mixed numbers, but how are we needing to subtract them? What are we going to be successful or know we're successful when we can do? Model it and explain it. But what are we wanting to connect it to? Strategies that we should know about or do know about, and the ones that we just went through. So the regrouping strategy and the adding up and the keeping a constant difference. I want you to try some of those strategies as we solve this problem. So how many of you are in the Boy Scouts or Girl Scouts? Anybody in the Boy Scouts or Girl Scouts? Cub Scouts? Oh, it's not Boy Scouts yet, maybe at this age level. So the task that I'm just passing out, if you don't mind, you're in what?
Boy Scouts.
Boy Scouts, awesome. So the task that I just passed out to you guys, if you would give one to everyone at your table, is about a Boy Scout troop. Okay, and in this Boy Scout troop, they're collecting, making a project. You know, in Boy Scouts, they make lots of projects. Girl Scouts, they do lots of projects, right? So these guys, Blake, Chris, DeAndre, Hector, and Tyrone, are making a project and they need some wood. Okay, you see that in part one? So for the project, they're going to use a certain amount of wood. How much wood does each person have left? So we're trying to figure out how much they have left. So how much did they start with? 5 feet of wood. How'd you know that? I didn't even know that. Oh, the problem tells you, right? Because where do we find our, math is bossy. Math kind of tells us what to do. We just have to read it. So bossy math. It says we have 5 feet of wood and that we're taking these pieces off. Blake's using 2 1/3. Chris is using 1 3/4. DeAndre is 4 4/6. Hector is 3 2/3. And Tyrone is 2 1/2. Okay? So we're going to work on figuring out how much wood they have left as a group. And I know that you guys work in groups a lot, but remember your expectations for me is that everybody is participating, that everyone is contributing, and that you're not just sitting here doing all the work while everybody's just sitting there. You're gonna work as a group. You're gonna talk to each other about those strategies. I wanna hear I'm gonna write them up on the board in case you forget, but I wanna hear you talking about, well, we regrouped, oh, we added up, or we kept the difference the same, or the distance the same as we solve these problems. So feel free, you don't have to do part 2 and part 3, by the way. You can go ahead and put a little X through that. We're not doing part 2 and part 3 today. We're only working with that part 1 with the chart. Are y'all with me? Do you know what you're going to be exploring for the next 10 to 12 minutes? And what strategies you're going to be using? The strategies we showed us, what were they called? What's one of them? Regrouping. Adding up. That kind of interesting one, the keeping a constant difference. Like, can we change both of the numbers by a little bit and make the math a little easier for us, right? Okay, so you got 10 to 12 minutes. You're going to be working with your group, and I'm going to be coming around talking with you as you explore. You can open up those bags. There should be, except for my tables with 3 people, there should be 2 bags per group, so you can work in partners if you want, or whole tables. So 10 to 12 minutes, timer is going.